In section 1.2, we're going to look at different ways that we classify the data that we've collected. As we talked in the earlier video, whenever we collect data from a population, either through surveys or through observations, there are times where we have numbers that we've collected. There's times we have names and labels, yeses and nos, these types of things as our data. So we can differentiate between these two, and it's a little bit, it's not exactly, but it's kind of like the non-numerical stuff and then the numerical stuff, like numbers and then categories and names. So the first type of data that we have is we call qualitative data. You will sometimes hear me refer to it also as categorical data because it's a little easier. Categorical, I think, is a little less, a little more well-known word. It also doesn't look like the other category that we're going to look at next, where both qualitative starts with a Q. The other category that we're going to look at also starts with a Q, quantitative. So at any rate, one thing to remember, qualitative, quality, we're describing something. Like if we're describing the different majors, right? In a database at this school, we might have a list of students and their at least declared majors, right, in a database. So those majors might be business or education, or those are all names, right? So qualitative data consists of attributes, labels, or non-numerical entries. Place of birth, that would be like, what city are you from? Or what city were you born in? Eye color, these type of things. Now, we say non-numerical, but there are types of categorical data, qualitative data, that involve numbers, but numbers that don't really have a numerical meaning to them. In other words, they're not counts or measurements. They're labels, but the labels involve numbers. Okay, and we'll look at a couple of examples of that. But the major point there is that some qualitative data some qualitative data involves numbers. It's just numbers that don't really have a numerical meaning to them. The other category, this is really, we just call it always this, quantitative data. And it consists of either measurements that we've taken or counts. So age could be a measurement. It could also kind of be a count of the years, depending on how specific we want to be. If we wanted to, we could take age up to the hour, minute, second of somebody's life, right? So we could get more specific with it. Weight of a letter, that would be a measurement. Temperature, also, that would be a measurement from a population. And so if we wanted to also know the number of dogs a person has within a community, that would be a count, right? So counts or measurements all consist of quantitative data. Okay, so the table shows sports-related head injuries treated in U.S. emergency rooms during a recent 5-year span of several years. Or several sports, 5-year span for several sports. Which data are qualitative and which are quantitative? This is pretty easy. Here we have the type of sport that was being played. So this is data. It's data that we collected. We said, okay, basketball. These are all categories. So this is the sport that we're playing would be the qualitative or categorical data, where the number of, which is a count, number of head injuries treated, this would be counts or measurements. These, in this case, would be a count. And so this would be quantitative data. Quantitative. You can see why categorical is a little bit, it's more different than qualitative, and a little easier to remember too, I think, for a lot of people. I want to give an example of a number that might be, that you might think, oh, it's a number, so it's quantitative. But for example, the Seattle Seahawks, they have jersey numbers. Unfortunately, one of them is now gone, which we don't need to discuss that. But I guess every year, certain players get traded away. This year we had Russell Wilson for the Seahawks got traded away. Very sad. But regardless, the jersey numbers of the Seattle Seahawks, that would be data, and those are numbers, but those numbers are really representative of the players who are behind those numbers. If somebody has a jersey number of 3, there's really no meaning to that number, right? If I take the average of the jersey numbers of people who played in a given game, that wouldn't really carry any kind of meaning. So one way you can tell whether a given number is categorical or whether it's qualitative, whether it's categorical or whether it's qualitative or quantitative, is to say if I do number stuff to it, if I do some number crunching with these numbers, is it going to produce anything that's memorable? Not memorable, but useful to me. Is it going to give me any insight into like if I took the average of all the players, that I would probably come up with something that's like a decimal. And that would definitely mean nothing as far as like jersey numbers go. So there are different datas that may have numbers in them, but they don't have real numerical meaning. If they're not a count or a measurement, then they are categorical or qualitative in nature. Okay, so let's also look at levels of measurement. And as we get higher in these levels, the more stuff we can kind of do with these numbers. So we start out with the nominal. And I'm just going to give you all these before we discuss each one. But nominal is the first one, so I'm going to write that down here. So we have nominal. And then above that, we will put ordinal. Above that, we have interval. And above that, we have ratio. So this is the highest here. So the numbers that we can extract more information and do more stuff with and get something meaningful is up here at the number 1. Ratio data is data that we can really do a lot with and a lot of analysis with. Nominal, which is just consists of, well, we'll talk about it here, is the lowest form. So there's not a whole lot we can do with it in terms of analysis. All right, so let's start off with nominal. Nominal level of measurement is qualitative or categorical data only. So it's categorized. We're using names, we're using labels and qualities. That's qualitative data. But there's absolutely no mathematical computations that can be made, right? All we can do is collect those yeses and nos, or those eye colors, or those majors, and we can like organize them and figure out percentages of how many were of this group, how many were in this group, percentage-wise or count-wise. But that's all we can do. We can't really do much. We can't take the average of those or anything like that. One level above that, the ordinal level, it's also, well, qualitative, but it can also be quantitative as well. But it's ordinal, meaning that the data can be ranged into some sort of order or ranked in some order in some way. So it's just one step above, say, here where we only have names and labels. Like, for example, the majors at a university, those don't really have any kind of ranking to them. And there's no way for us to really organize those in some sort of ranked or in a way that makes that has meaning to it. The differences between data entries is not meaningful. Okay, so let me give you an example of an ordinal level of categorical data or qualitative data. Might be t-shirt sizes, right? So t-shirt sizes, we have extra small, we have small, then we have medium, we have large, we have extra large, and however many triples you want to, doubles and triples, large we want to go. Right? So those are simply names that we've attached to certain measurements of a shirt, but there is some sort of order to them, right? And so they could be sort of ranked in a way. You could also be filling out like a classroom evaluation, and you're ranking between 1 and 5, right? 5 being loved it, 1 being hated it, right? So those are numbers, 1 through 5, but those numbers really are representing feelings or something that's really non-numerical behind it. And there's an order to those. But so they can be ranked, okay? But they involve numbers. So they would be, they might actually be quantitative in this case because we could take averages and stuff and that they would make sense. So those are the first two. So let's decide whether the data we have here is nominal or if it's at the ordinal level. And here we have the top 5 U.S. occupations with the most job growth. So we have personal care aides, we have registered nurses, we have home care aides, combined food preparation and serving workers, including fast food, and then retail salespersons. So these are different categories of jobs, but they've been rated according to which ones have the most job growth projected for 2024. So this would be ordinal. We have definitely qualitative data, categorical data, but there's an order, there's a ranking to those. So there's some semblance of order we can give them. Movie genres, action, adventure, comedy, drama, horror. Well, those are simply categories. There's no natural order that we can give to these. They simply represent different movie genres. So these would be nominal in nature. Let's go to the interval level of measurement. With interval, we have to be using quantitative data. The data can be ordered, so there's an order to that data. The differences between the data entries is meaningful, and this is the most important part here. The 0 represents a position on a scale. It's not an inherent 0, meaning 0 does not mean nothing, does not apply, does not mean none. This is really the key difference between interval versus the next level of ratio, which, let's look at that. For the ratio level of measurement, it's similar to interval. There's a very distinct difference between them, but it's a very slight difference. The 0 entry is an inherent 0, meaning nothing, none. A ratio of 2 data values can be formed. So if we create a ratio, it's going to give us actual helpful information. One data value can be expressed as a multiple of another. This ends up being the biggest thing, is the 0 entry means nothing, means 0 means none. And we'll look at a couple of examples here. All right, so we have 2 data sets. Which set consists of data that's at the interval level? Which data set consists of data at the ratio level? So here we have the New York Yankees victories, and so a bunch of years, basically, what we have here. And over here we have the number of home runs of each team for that particular year. 2016, I guess, is what we have. So thinking about the 0 aspect, because both of these are numbers, right? These are years, and then these are counts of home runs. Thinking in terms of 0, if a team, none of them did here, but if a team had 0, would that have a meaning to it? Would that mean that they got none? And yes, it's probably not true of any team, but if there was a team that had a 0 with it, that would mean literally that they had 0 run totals that year. And so this fits the ratio level, whereas over here it does not. Here, if we talked about the year 0, does that mean that there was no year that year? Or right? So what would the year 0 mean? Well, it'd be just the arbitrary starting point that we said, okay, this is where we have year 0. So in this case, 0 is really an arbitrary value that we found that is kind of this measurement that we've constructed. It doesn't mean nothing. Whereas here, a 0 actually would mean something. It would mean 0 home runs. Okay. So this one would be at the interval level, whereas this one would be at the ratio level. Interval, because 0 doesn't really have an inherent meaning. It doesn't mean none. It does represent a point in time, but that's something that we've constructed. Another good example is temperature. Temperature in Fahrenheit and Celsius both have different scales, and they both would fall into the interval level of measurement. Why? Because 0, like 0 degrees Celsius, 0 degrees Fahrenheit, have totally different meanings, and they're totally random from how we put it. On the Celsius scale, 0 would be the place at which water freezes, the freezing point, right, of water. On the Fahrenheit scale, 32 is where we have the freezing point of water. And then 212 is the boiling point of water on the Fahrenheit scale, where 100 is the boiling point on the Celsius scale. So both of those, the 0 really doesn't have an inherent meaning to it. It doesn't mean the complete absence of heat, which is what, those scales are trying to measure. They're trying to measure heat. So there is a temperature measurement scale, and it's called the Kelvin scale. 0 on the Kelvin scale does mean the complete absence of heat, if that's really possible, but they figure it is. So the Kelvin scale would be at the ratio level, but not Celsius or Fahrenheit. So to kind of give you this table here that you might find helpful, it's like, okay, if we can put data into categories, there's our beginning point. All of these, that can work. But if we want to put them into some sort of order, the only thing that can't do that is the nominal level. If we want to subtract data values, well, we can do those with interval numbers or ratio numbers, but we can't do them with ordinal or nominals. Those subtractions would not necessarily have any meaning, right? If, for example, we subtract 2 Jersey numbers, what does that tell us? Right? It doesn't give us anything meaningful. There are times where you might actually be able to subtract 2 data values, but that subtraction has to have meaning, and that's the same with this data multiplier idea. Again, they're trying to give you another way of looking at the interval versus ratio here. I think it's a little harder for us to see that as like, well, what's the difference there? If we could double these, but does that doubling have any kind of meaning to it? And like, if we double 2 temperatures, does that mean we've doubled their heat? Well, kind of, but it's on a different scale. It's not inherently that way. It's only within the Fahrenheit scale, right? Have we actually doubled the quantitative heat of that day or what have you? Not really. We've done it on a scale, but not. So that to me is a little harder to use as a way to differentiate between interval and ratio. I think the smartest way to go with interval and ratio is to ask, does 0 have an inherent meaning? Does it mean a complete lack of something? And if it doesn't, then it's not ratio, it's interval. If it does mean the complete absence of, then it falls into the ratio category. So just a couple more examples here. On the nominal level, we might have, they're giving us an example and then meaningful calculations that we could do. So we have like types of shows televised by network. So we have all these different categories that shows might fall into. And what can we do with it? Well, we can put them into categories. Like that's all we can really do. If we put it, a show televised by the network could be put into one of these 8 groups. And maybe there's more. But regardless, that's the only real kind of calculation we can do. Group them together, get a count, get a percentage, right? So there are things we can do with them, it's just limited there. Ordinal. So we have the motion picture. Here's a great example where we have our G, PG, PG-13, R, and then NC. So there's a bit of an order to this, right? With each level, there's a level of restriction that we've put on who should be seeing these things, right, by age. So we can put it in a category and we can put it in some sort of meaningful order. PG rating has a stronger restriction than a G rating. Moving on to interval, average monthly temperatures in degrees Fahrenheit. So here we have a bunch of temperatures, right? And these are in Fahrenheit. We would need to know that in order for these numbers to really have any meaning to us, because we're somewhat familiar with the Fahrenheit scale. We can put a category. We can put it in a category. We can put them in order, and we can find differences between them. So if we subtract the 2, we found a difference there of 9 degrees. So it was 9.1 degrees warmer. But if we doubled them, that doesn't mean they had twice the heat, and that's why it would just mean it was double on that scale. But we didn't actually double the inherent nature of what we're trying to measure, which is the heat, right? If we go from 30 to 60, that's a doubling of that temperature value, but it isn't necessarily a doubling of the actual heat of that object. And so that's where it's different. We can subtract, but the ratio, the multiplication of those doesn't really have much of a meaning to them. If we go from, let's stay. I'm going to stick with that. So ratio levels, here we have monthly precipitation of rainfall, right? And so we could say that between something that's 3 or close to 3, like September and October, September has almost double the amount of rainfall of October, right? That actually has a meaning to it. Or in this case, they took a 758. I'm not sure which one that was. Okay, it was June's divided by, what's 3.7? March. And we can say that those 2 months, that the first one has about twice as much, approximately double the other one. And 0, here's really what we would say. 0 would actually have a meaning. It would mean 0 precipitation within that month. And that's the best way to look at the difference between interval and ratio.